Welcome, Spencer.
Hey,
I'm super excited to get more details on how this actually works and why this is actually even performant, because that's always what I wonder next, right? When it's about how to do vector graphics in a performant way on our current hardware. So, Spencer, here are your slides, and take it away.
thanks. Thanks, Stefan. So today I'm going to be talking about compute-centric vector graphics, and we're going to be answering that question of why it's performant to render vector graphics. A little bit about me. My name is Spencer Claude Imbleau, and I work as a software engineer for Blue Origin. That's an aerospace company founded by Jeff Bezos. Before then, I worked at NASA, and the way I got into Rust was in 2019. I was rendering a thesis on vector graphics at the time, and back in those days, Velo was called Pete GPU. I've stuck with it the entire time. So this is a multi-year kind of passion project on the side. It's not really related to my work, um, but it's something I've really enjoyed ever since. So we're going to start with just some necessary context to understand what vector graphics are and what Velo is. Uh, so there are two competing imaging models, raster graphics and vector graphics. Raster is the traditional graphics model that you would always think of. You have hundreds of rows of pixels encoded in an image, and that has long stayed as the favorite child of GPUs. It's what the graphics processing unit prefers. Vector graphics, on the other hand, are images that are encoded with points, lines, and equations. So it's an implicit encoding. So because of that, there's less data in the file. It often has a much smaller footprint and is better for networking, as well as it's infinitely scalable. So you don't have the same jagged edges that you would get whenever you try and upscale a raster and you see all the pixels. It's infinitesimally precise at any scale. And the image is derived through varyings. Varyings is like your camera scale, the view box, the section of the image you want to actually look at. But in order to derive the final image, you need to do some computation. So we're going to be talking a little bit about what is the naive rendering of vector graphics. If I wanted to actually render an image, and I know that the frame buffer looks like this, where we have two circles, how do I know if this is a blank white image at the end if I was to rasterize this? Is it a blank white image with a black donut, or is it the opposite? Is it a white donut on a black background if I have just two circles encoded in the image? So in vector graphics, you have to solve this problem yourself. And so here are the two side-by-side examples. Is it the left or the right? And if you want to solve this naively, what you could do is you could kind of ray march from the left to the right, and then you could count up the intersections amongst paths that you find. So if I'm going from the left and I'm just marching along and I'm going to count up one intersection right here, I continue to go through and count up a second intersection here. And then at the end, what you'll find is if you keep a sum of all the intersections, kind of like in a prefix sum, you'll find there's no intersections going from left to right at the top. And then the next row, you have 0, and then you hit a path here, and then it's 1 all the way until it hits the second intersection, and then it's 2 until the end of the image. And then in the middle of the image, there's more intersections here, so it goes 0 to 1 to 2 to 3 to 4. And this gives you a mathematical kind of array model of the intersections. And using this prefix sum, you can decide if it's even or odd. And if it's odd, then you can say that that's inside the image. And if it's even, then it's outside of the image or shape. I'm gonna say shape. So henceforth, we know that this is the correct representation of of that image if it was just two circles. It's actually a donut. So that would be just one way to naively think about how could I render, a vector image if it's like an SVG. But if you want to actually scale up this problem, it becomes more complicated. So imagine if we had 100 shapes on the screen, that becomes a lot more difficult to scale up. And if you're doing a lot of that on the CPU, that's going to have implications on the frame rate. It's not going to parallelize easy. And particularly, vector graphics suffer from what's called a locality issue. So if we add just one more circle around the original donut, then we get a completely different image. It would turn into a bullseye or like a target down here in the bottom right. So just by adding one more path, the image could be completely different. So the locality issue is that you need to know every single path in the image really to be able to derive whether or not a pixel is filled or not filled. And the GPU is just not built for this type of computation at all. There's nothing in the traditional GPU architecture that accounts for this. And you could theoretically shoehorn a lot of the computation into the standard pipeline that has existed for decades now, which is like the vertex shader, the geometry shader, rasterization phase, fragment shading. However, that's very hard to do and comes at complexity, and it would be extremely hard to maintain, probably, since you're trying to solve a problem in a space that doesn't that has a lot of battle against you. So Velo is a vector graphics renderer that has been kind of championed by Google for a few years as a compute-centric vector graphics renderer. And by compute-centric, what we really mean is that we're using compute shaders, which are programs that can do arbitrary compute on the GPU, to directly process the vector graphics. And why you may not have heard of that really until recently is that compute kernels in the underlying hardware has been relatively inaccessible or non-existent before about 2015. In about 2015 and so forth, the hardware access to compute kernels and actually being able to use them has become more accessible over time for things like AI and CUDA and other applications. And now it's starting to really be easier to do on the software side. So WebGL, for example, has no notion of compute shaders. You cannot use compute shaders in like WebGL. Now, with the new emerging web GPU spec that is evolving and becoming more stable in browsers, you're able to actually use compute shaders. So there's been multiple points of friction where we have hardware access and then software access as well. But Velo has become a technology that you can directly process the vector graphics using compute shaders and then provide an API to developers. And it's a very feature-rich SVG-like API for drawing vector graphics. So your standard fills, strokes, gradients, text, images, and when I say images, you can also embed raster images using Velo, as well as like clips and blends and various other rich styling. All that's available in Velo. And I think where Velo really shines is that it's suitable for highly dynamic scenes as well. It doesn't rely on pre-computation. So a famous example of this would be Valve really pioneered the signed distance fields. So if you ever look up SDFs, you'll typically find a Team Fortress 2 image of text being rendered with signed distance fields. That would be an example of pre-computation. As well as there's no performance landmines with Velo. You should see a linear trend of how many curves am I really rendering here? And the linear trend would be the more curves, the lower the frame rate. You're not going to see any cliffs or spikes or exponentiation at all with Velo, unlike your web browser, which is backed by a vector graphics renderer called Skia. So something like the SVGs on your web browser being rendered are being handled by Skia, and it's really optimized for the minimal set and broad case of vector graphics like an SVG on a website. Where it doesn't shine is like heavy PDFs and Google Maps that you might notice those things are not well optimized on web browsers. So I'm happy to say that Velo kind of circumvents a lot of the performance landmines that you might find. And all that is to say, Velo has a very complicated shader pipeline. It's not something I understand at the implementation detail level. This is headed by postdoctoral experts at Google, and it's being funded by Google. So this is just a slide taken directly from Rafe Levian's presentation on Velo. So if you have questions directly about Velo itself, I recommend going to the Linebender Zulip chat and asking the experts that work on Velo directly, and there will be a link to that at the end. What I have developed, however, is Bevy Velo, and what that is it's an integration to use Bevy assets, use assets in the Bevy game engine, and we have support for Velo scenes, which is kind of like the raw way to interact with Velo. So we have the ability to render just direct Velo scenes if you want to use the Velo API. We have text support through Parlay, which is all Rust based, so no like Harfbuzz or any C++ tooling in the chain. We also have SVG support through a subcrate called Velo SVG, which directly translates SVGs into Velo scenes. And then we have Lottie animations as well, which is exposed through the Velato runtime. So with Velato, you get both a runtime and the actual translation to Velo scenes. And then in progress, we have .Lottie animations, and Lottie Lab is working on an interactive Lottie format. Lottie is a relatively new thing as well, so don't feel bad if you haven't heard about that. Lottie is a new standard for vector animation formats. It recently became a Linux Foundation open source standard, and it has an action committee around it now. So some use cases just to go over of why you might want to use Bevy Velo. If you want to make video games, if you want to do UI, if you want to make a commercial vector software, so like Figma, if you wanted to recreate Figma, I think that's a ripe opportunity for Bevy Velo, as well as if you wanted to work with vector graphics natively, so like something like a font editor, since fonts are vector and scalable. And also I just wanted to plug a little image attribution here. Cart, the creator of Bevy, he has been experimenting a little bit with Velo, and I thought that was really interesting and integrating that for UI cases. So now I really want to show what Bevy Velo can do now that you've heard so much about it and how it's been used. So I'll start with just the basic Velo demo, but we'll kind of go through the list. So here's actually Velo being run on a web browser. So we see here the GhostScript Tiger. That's kind of like the hello world of vector graphics. We also have various other little tests that you can cycle through. So things like stroke caps and dashing and anything to do with strokes. Strokes are also done completely on the GPU, so no CPU interaction really there. We also have emoji rendering and other things. So here's kind of the even odd fill rule that we showed in the very beginning. We have some various complicated rendering tests just to stress test in some cases, as well as animated and variable width text. And then here's even a raster image that you embed. Now, you'll notice with the raster image, you get those jagged edges if you zoom in, but with vector graphics, that's not going to happen. You'll never see a pixel there. Gradients and other various things. So here's an example of a clip behind a gradient, and blend modes. There's a lot of rich styling opportunity with vector graphics that you just simply can't do with raster. That's really useful. Some of these are just rendering tests and various stress tests. So like this would be a good example of a stress test of just rendering as much stuff as possible. And all this is running on the web browser. Here's a motion mark test, which is a standard test for evaluating vector graphics, and you can kind of go up and down in the amount of paths you want to render. And then yeah, so that's the basic Velo demo. Now this is just using basic WinIt. It's not hooked into Bevy, so that's kind of the difference here. We also have plenty of other demos. So there's a Bevy Velo demo, which this is using this is just one application of Bevy Velo, but we have a Lottie animation here, which has transitions and themes, and it's hooked up to this rich state machine. So if I mouse on, the animation plays. If I mouse off, it goes in reverse. And there's tons of things you can adjust with it too. So I can like stop the state machine. I can play it, lower the speed, go to reverse, lower the speed on that. So now if I play it, now it's gonna go a lot smoother, a lot slower, let go, a lot smoother, a lot slower. As well as you can do things like dynamic color remapping, since Velo is a vector graphics are an implicit format. So a lot of the things you can change at runtime. So you can change paths at runtime, you can change colors at runtime, you can remask certain layers. So that's just an example of Bevy Velo. Here's an example of a Lottie file in general. This isn't running on Bevy Velo, but Bevy Velo has direct support for Lottie as well. So we just saw I was running a Lottie file in Bevy Velo. It was the calendar. Here's another Lottie example. This comes directly from Google Fonts, the same team that's making Velo. There's open source Lottie files for pretty much any emoji. So all of these will render in Bevy Velo as well, in case you were ever curious and wanted to run it yourself. Close out of those. And then here's an example of a game that I built with the help of another colleague. His name is Sebastian Hamill. And this is an example of an actual Bevy game being used with Bevy Velo under the hood. So we can zoom in anywhere and see there's no loss of resolution. I can zoom in on anything from the tiger's eye to his whiskers and really never see a pixel. So all that is just working natively, and in the browser can control the pieces of bacon, and it's kind of like a little game of Pong. It's not too intricate, but it's a good example of just Bevy Velo in actual use case. So what's cool also about this is that vector graphics, since they are implicit in the actual image, you can take the underlying paths and the data structure in the image and convert that to like physics colliders. So in this case, the egg, the colliders are not being added manually, whereas in most other game pipelines, you're going to want to add your own colliders. In this case, the colliders are being automated because it takes the SVG of the egg, it derives a convex hull around the egg, and then uses that as a physics boundary. So lots of cool different ways to uniquely use vector graphics that could represent an overall positive delta in game development like that. So tons of cool ways to go. We also have integrations and people using Bevy Velo in the wild. So a really good example I want to showcase is there's this really cool library called Bevy Motion GFX, which they're using Bevy Velo to render these really neat, cool vector graphics. So they have integration with types, which for those who are familiar with LaTeX, it's kind of the same thing. It's a replacement to LaTeX. So you can do these nice rich animations for things like YouTube videos and really make some visual appealing looking things. There's also the game I just showed you, which is called Vector Graphic Pong, or Vong for short. There's a spline editor that I've seen been done, and then also I have a game studio that we're developing a little game called Wootnoots, which I'm not ready to share that today, but it's in development. We use Bevy Velo for pretty much the entire stack. So that's basically all I had for demos. The usage of Bevy Velo is actually really simple. So if you're curious, how do I render an SVG or a Lottie? We have tons of examples. So if I want to know how do I render an SVG, which is a pretty common use case, there's a very simple, just 20-line example. You have to spawn your camera, and then you just spawn a Velo asset bundle where you use asset server.load, and then you provided an SVG. And it really is that simple. If you wanted to do the same for a Lottie animation, it's likewise just as simple. And if you wanted to experiment with scenes, you could do that. We also have an example with Scene UI. So if you wanted to use Velo's native scenes for things like checkboxes and things for UI, that's in the works. Or you could do the same thing that we did in the Bevy Velo demo, which is use an actual Lottie file kind of as a UI component. So you can see how this could maybe be extended to be a button where you hover. So lots of opportunities, not just if you wanted to write code, but if you wanted a designer to design the UI and buttons and then add state machine transitions like on mouse enter, on mouse click, and hook that up programmatically. And I think we have a lot in the works for that. That's really cool and coming out. But yeah, that's the end of the actual presentation for Bevy Velo, and I'm able to take questions.
Thanks, Spencer. Amazing stuff. I now I want to throw it in my project and give it a try. Yeah, we have a bunch of questions. Let's see. So what's Google's game plan with Velo? Will they power Chrome's SVG at some point?
That's a really interesting
If you know
question.
anything about that.
Yeah, so I do not work for Google. So there's sometimes a lot of questions about whether or not Velo is a Linebender thing or if it's a Google thing. And Linebender is this open source organization that works on things like Velo and Velo SVG and Velato and Bevy Velo. So I'm in the Linebender organization. But Google is specifically funding Velo. And I think it would be a great thing if the work from Velo gets integrated into like Skia, for example. That's your browser's vector graphics engine. So that way, things like slow loading PDFs just go away for all users of web browsers. I think that is a great example of how Velo particularly could help out a lot of people and start getting integrated to technology that millions and billions of people are using. However, I don't know what Google's plans are, and I think a question like that could go to the Linebender Zulip chat where you ask the Google employees directly.
Yep, noted. How does Bevy Velo play with Bevy UI? I guess in terms of clickability and stuff like that. Is that will that work out of the box?
Yeah. So You can attach scenes to nodes, and you can attach images to nodes, and they will take up the bounding box of the UI node. So it will just
Mm,
automatically scale to UI nodes. Since vector graphics, you can scale them in X and Y, and you can do all these transformations to
mm,
them. It should just work exactly as you expect. And we have a great example of that. It's called the scene UI example, where it uses a UI node and then draws a like a check mark over that, and there's hover and click logic to dig into if you're interested in how to use Velo for UI.
okay, so that would also be an example then if I wanted it to be like per pixel. I mean, at the end, it's still a matter of pixels, pixel perfect hovering and clicking. If there's like roundings around the edges and stuff, is that also part of this example? Because otherwise, it will still basically just recognize the whole rectangular size that you mentioned of the node as the hover area of the thing, right? If I wanted
Yeah.
if I wanted to ask Velo, hey, is my cursor really in this SVG or not? Is that provided?
Yes, so that is provided as part of some of the new experimental .lottie work that's going on. Um, However, hooking up hover events and things out of the box for scenes specifically, that is something you'd have to implement yourself, and there is an example of that in the scene UI. However, you should not see any jagged edges or pixels using Bevy Velo at any time. That would be considered a bug. We do take the we do take the pixel density of your like monitor and example, and we do the appropriate resolution scaling. So just to make sure.
Gotcha. Okay, that's cool. And the next question is, I've not used Lottie, but does it have a what you see is what you get editor for these animations? Because that looks like a powerful authoring way then for content in Bevy, I guess.
That's a really good example, and or that's a really good question. So there are new tools that are coming out specifically to edit Lotties. I would really point to lottielab.com. They are a really rich, powerful Lottie editor. I'm not sponsored by them to say that. I just everything I've been doing to make Lottie animations or test out with Lotties, I've basically used their tool. But I think
Mm,
more players are coming in the commercial atmosphere for this. So there's lottielab.com. There's phase.com, which is coming out with a Lottie tool. There's lottiefiles.com, which is coming out with a Lottie editor, and but it's a very quickly moving space. Lottie
mm,
files, the actual format is relatively new, I would say within the last 5 years. So when I started to research vector graphics back in 2019, or even earlier, for thesis work, Lottie didn't exist. So this is still kind of new. Um, so there's new tools that work and that you can use
mm.
right now, and some of them are free, like lottielab.com.
That sounds really cool. I mean, that's at least covering some parts of the non-existent editor that might people look for, right? And
Mm-hmm.
let you author some of the animations and graphics in a Bevy game. Cool, cool. Can you make a website, not a game, with Bevy Velo or integrate it with Leptos or Dioxys?
That's a really good question. So I haven't used Leptos or Dioxys. I've used U before. Um, and yes, I'm certainly confident that you could do that. However, you'd be kind of constrained to having Bevy run in a canvas. So
Mm,
if you're looking for native, put the SVG and control an SVG on the DOM, that's a different story. That's not going to be possible with Bevy Velo. Um, but if you want to render within a canvas and then embed that in your website, that should be totally doable. Everything in Bevy Velo is able to compile and run for native, web, and it should also work for Android. iOS is a little untested. I don't think that's an official supported target of Velo, but it's not something that wouldn't work. It's just that given that it's being championed by Google, it's something where Android is going to be the first player to get official support there. Not to say that there's
Yeah,
any barriers or roadblocks, though.
no, makes sense. Okay, so what's the next one? We had that one. When web GPU in all browsers? Well, that's that's again not really to the topic, but I guess there is a point, right? It will not work in, I guess, Safari right now. Or what about Firefox? I'm not sure about web GPU in Firefox.
Also a great question. So web GPU has been one of those slowly stabilizing technologies. When I first started doing these experiments, none of the browsers had stable web GPU support. There was tons of bugs. And slowly Chrome has stable web GPU support now. Firefox, you can get it working with a flag in the nightly version of Firefox. And Safari has technical preview for web GPU. But I think all in all, right now, as of, I don't know when you're going to watch this recording, but as of July 2024, Chromium-based browsers are the only browsers that have stable web GPU support, which accounts for about 77% of current worldwide browser usage. So the remaining amount of browsers should get supplemented by CPU fallback that Velo is implementing. So instead of needing web GPU compute shader support, you can fall back to CPU rendering. That being said, that's not going to be a real
That's not
good
going to be great.
fallback if you're looking for games. If you're looking just to
Yeah.
render SVGs and lotties a few times a second, or just simply rendering, like making an SVG renderer or a lottie renderer, that should be fine with CPU fallback. But I don't know how performant the CPU fallback will be. It's not something I'm looking into, and it's not something that's complete either within Velo, but it is being planned. I would say, based off previous research I did in my thesis, which is a few years old now, back then CPU bound vector graphic rendering is on an order of magnitudes slower than compute shader rendering. So that is to say, compute-centric rendering should be the state of the art now. It is a massive technology leap compared to how vector graphics used to be rendered. I would even venture as to say it's about 10 times quicker. Mileage will vary. That's a very rough estimate, but I would stand behind that.
Yeah. Okay. There's a few more questions that popped in. So if we still have a few minutes of your time, how does rendering SVGs compare to rendering sprites or images in terms of performance? That's an interesting one.
Yeah, I can't really compare those two meaningfully. When you render a sprite, it's going to use the standard Bevy rendering pipeline. And when you render with Bevy Velo, what's going to happen is, for one, you're going to load up the asset with the asset server. That's going to parse the SVG or parse the lottie, and then it's going to spin up an intermediate renderer so for something like a lottie file, it's going to translate the SVG in memory to a Velato renderer, and then every frame you're going to request a new frame, and that encoding is very cheap and easy to send to the GPU. So there's not a lot of real performance overhead with with rendering. So here's a good example. I have a good image for you. So here's 100 peacocks all being rendered in an animation all at once. So and all of these peacocks have hundreds of paths. So this is something that I think there's a lot of potential with the current pipeline. It's very performant.
Hmm.
I just think your perception of how you're going to measure things is going to change. So instead of thinking of like triangles per second, you're going to think more in terms of like curves per second, or you're going to have certain limitations on web, or you're going to consider your platform and the limitations it has. You shouldn't really be bottlenecked on any specific thing. Like I said, there's no performance
Hmm.
landmines with Velo.
Yeah, and it's really hard to make it like a meaningful comparison, like an image
Mm.
that you render a million times versus a SVG that you render a million times. That's really hard to compare.
Yeah.
um, the last one is a bit cheeky. Will Bevy compete with 3JS?
um, that so that's a question about Bevy. So my opinions on Bevy are very good. I mean, I would say that Bevy is the most ripe game engine right now in the Rust ecosystem, and I I want to continue contributing to the Bevy space. Um, so I think any good engineer is going to use the right tool for the job. So if you have a very simple task and whatever work you need to do in for rendering a 3D model, maybe 3JS is the best solution for you. Maybe you're better off just finding an open source model viewer that's just ready to render your model. But in terms of a game engine that's written in Rust, I think Bevy's the most promising right now, especially because of its selling points being code first and having an open source foundation, and it seems to be done very responsibly. So I'm very happy with the direction Bevy's going in, and happy to see Bevy Velo be a part of that.
That couldn't have been a better ending to this conversation, I would say. Thank you so much, Spencer. And it was a great presentation, super informative. And I'm really excited to give it a try, especially looking at these authoring opportunities with Lottie. That's really exciting. So keep up the great work. I'm definitely going to follow this closely. Thank you.
All right. Thank you so much. It's a pleasure to be a part.